Hello, everyone. How is it going? Let me share my screen, but before I share my screen, I first want to make sure. Hello, Razan. Oh my God, I'm so excited too. All right. So before I start, here's the Q&A. Yep, Miss Saba is here. All right. Reem Amjad is here. Reem Amjad, welcome. How are you? Okay, so before I start, I want you to type on the chat and let me know if you can hear me well, if you can see me on the screen. All is good. Just want to make sure. Hello, Doha. All good? Okay. Can you guys type on the chat? I don't think so. Panelist chat with everyone. Okay, yeah, hold on one second. Attendees can chat. Here you go. Can you chat now? Can you put on the chat now? You can see and hear. Awesome. Awesome. Jude, Iyad, Lujain, Lana, Abdurrahman, Ahmed, Haya, Shad. Oh my God. Thank you so much for being here. Okay, let me share my screen. So today is our first session. Okay, it's going to be a 2-hour long session. Okay, so but it's gonna be fun. So do not worry. All right. Okay. Spotlight. Here's a spotlight. Okay. Thank you, Reem and Doha, for letting me know. Okay, how do I share my screen? Screen? I don't want to start recording. Okay, hold on one second, guys. I don't know what is wrong with my it says record. I am doing well. Mohammed Arnaout is here. Oh my God. Oh my God. Karma is here. That is so good. It is so good to see you. So Karma is one of my older students. This year she is gonna do the AS. Yeah. Okay. So zoom. Where do I find the link? Come on. Okay. All right, here you go. And Faris is here. Razan, tell Dr. Nervana. Oh, Mohammed Arnaout is amazing. So Mohammed Arnaout is actually one of ours, also one of my prior students, and he was amazing. And he is on our team also this year. So thank you so much for joining. Can you rename me to Ali Fudail? I don't think I can rename people. I don't know. Good question. Maybe someone can do. So we have actually several panelists here. Of course, me. Miss Dina is here. Miss Saba is here. Miss Rabia is here. So, and we have 2 chemistry assistants who are amazing. Miss Jana.
Recording in progress.
Sorry about that. Okay. All right. Miss Jenna, one of our amazing assistants, she's going to be taking care of the Q&A. All right. And Miss Razen is going to be taking care of the chat if you guys have any questions. All right, let's get started. You guys ready? Hands on the keyboard. Let me know if you have any questions. And I have good news also. We have Kahoot at the end, which is a lot of fun. It is a lot of fun. Yeah, my brother just finished A-levels and was recommending. Oh, Adam, did I teach your brother? That would be great. That would be nice. Yeah. Yes, I love Kahoot a lot. It is so much fun. And I will let you know if you haven't used it before. That's fine. I will let you know what to do. You just go to kahoot.it and you get started. All right, let's get started. It's already 4 minutes. I like to start on time. So just to let you know, starting from next session, I start sharp on time. So 9:00, I get started. If you are late, no, I do not allow anybody to be late. Okay. So let's get started. So today we're going to start with the first session. But before I get started, I really want to let you know something. If you are new to me, if this is your first time seeing me, I just want to let you know chemistry is happiness. Loveliest science subject on earth. My classes are a lot of fun. So go find your best place at home, hands on the keyboard, enjoy the 2 hours, right? Yes, Taha, yes. All right. So before I get started, also I want to know a little bit about you, and I'm gonna tell you also a little bit about me in case you don't know me well. My question for you is, what do you want to be in the future? Okay, I'm looking at the chat. What do you want to be in the future? Genetic engineering. Jude wants to be a genetic engineer. Yasmin wants to be a medical doctor. Nireen wants to be a Nireen, hold on. Doctor, okay. Rauda, dermatologist. Adam, software engineer. Muhammad, doctor. Still not sure. It's okay to not be sure. Robotic engineer, Ithor. Um, robotic surgeon. Ali, that's very smart because life is changing, right? Yes, robotic surgeon, that is so smart. Dentist or nurse, Hannah, that's a good one. Um, I like dentistry. Every time I go to the dentist, I'm like just thinking a lot about, the office and how they treat people, and there's a lot of good things around there. Orthodontist, medical doctor, AI, that's nice. Civil engineer, dentist, hopefully, psychotherapist. Actually, my daughter is all into psychology and stuff. She's very smart. Biomedical engineer, Sarah, Jenna, okay, dentist also, surgeons, several dentists, several engineers, several AI stuff, marketing, Layla. Oh, that's a good one. Maybe you can work for us because I'm not good with marketing, although Saba is good with marketing. All right, that sounds really good. You guys probably know that I am a teacher for sure, but I also consider myself an entrepreneur because I have my own thing and I own my own website and I develop my website not on my own. Of course, I hire someone to take care of the website. We have a software developer on the team. I also consider myself a researcher because I work at the University of Wyoming. I'm going to tell you about that in a second. I'm also a pharmacist. I don't know if you guys know this, but I'm a pharmacist. I went to pharmacy school. I actually went to 2 pharmacy schools, Cairo University and Purdue University. Crazy, I know. All right, so just a little bit about me. So you guys know my name. My name is Dr. Nervana Ihab Al-Khadragi. And again, I'm a pharmacist. I have a PhD in pharmacy. I started teaching my loveliest subject, which is chemistry. I started teaching in 2004. I helped hundreds of students in 2004, exactly in July of 2004. I had my first student. Her name was Maryam, in the city of Sharjah, UAE. And so she was my first student, and then I started like having an in-person. Students came to my house, and it was a lot of fun, especially when students came to my house. I myself was an IGCSE graduate in 1999. Do not tell anyone. Yes, I'm that old. I went to Cairo University in Egypt, graduated in 2004, became a pharmacist, and then I decided I wanted to do more. Because I always want to do more, right? So I went to Purdue University. Oh, Karma, you're so sweet. So I went to Purdue University, got my PharmD, which is called Doctor of Pharmacy, in 2008, got my master's, got my PhD, and right now I'm an assistant professor at the University of Wyoming. So that's about me. Very, very passionate. Doctor, why are you being so... Oh, Yasmin, you're so sweet. Okay. And also want to let you know, thank you, Yasmin, that I'm very, very passionate about chemistry. I just live and breathe and think and dream chemistry. My dreams are all organic structures. And so I published a book called The Joy of Chemistry on Amazon, which has really good reviews. So someone said here, this is a very clever, cute, brilliant, useful book that makes chemistry approachable and fun. Now, I want you to look at the word fun. All right. I really care about this. I want my classes to be fun. I want it to be enjoyable. And the reason is you guys are going to be working really hard. So at least have a couple of hours of in some kind of enjoyment. All right. Also, just wanted to brag about my prior students just a little bit, guys. We're gonna get started in just a minute, but really wanted to brag about my students. My students do wonderful. Guys, if you listen to me, if you do exactly what I tell you, you're gonna do amazing. So, Noor, for example, got 197 out of 200. You guys know what that means. She only lost 3 marks. Okay, that's it. Who else? We also got 198. Hannah got 196 out of 200. This is the class of 2024. Ele got 185 out of 200. By the way, Ele is on our team. Ahmed is on our team. Ahmed also got 198 or something. Very, very amazing, very impressive. The class, of course, the class of 2025 result is not up yet. It's not out yet. So we're waiting for that, but I'm very excited. I'm very confident. I know they're going to do amazing. Yes, Ale is on the team. Yeah. 2023, we also had some amazing students. Jenna got 196 out of 200. Amazing, right? Look at this. 196, 196, 195, 191. And all these amazing students are on the team. So Jenna is on the team, Omar is on the team, and many other of my prior amazing students are on our team, and so they're going to be helping you. Each of my student will get their own assistant, one of those amazing prior students. Umniyat is also on my team. Muhammad Ihab is on my. I don't want to forget anyone, and actually many of them are on this meeting today, so that's amazing. So please go ahead and scan this code. Also, Ms. Dina have already posted the link to these testimonials. I think it's like a 95-page document that has like a lot of like samples of what people said, how people were excited about their grades and how well they did. So please, yeah, 95 pages, just read a few pages, just enjoy. I think Miss Sabah have tried to highlight like the most important statements and stuff. Oh, I also want to let you know that Selma got 200 out of 200. Right now, she's going to be a doctor. She's in medical school. She got 200 out of 200. Can you guys imagine? And she is on the team. Yes, she's going to be helping our students directly. And so you guys have access to some amazing, amazing students. And so before I get started, some logistics here. If you have any questions, please post it on the Q&A. Ms. Jenna, who is lovely and amazing and just beautiful. I do not know what to say about Jenna, so I'm just gonna stop right here because I can talk 1 hour about Jenna, okay? So she's gonna be answering your Q&A, all right? Anything about chemistry, anything about the course, just post it on the Q&A. You guys can find the Q&A button here on the Zoom somewhere at the bottom. Can you find it? Just let me know, just say yes, or the letter Y. Yes, okay, awesome. Yasmin, Nireen, thank you very much. Now, if I'm asking you a question, I would love to see your participation. Just like you guys are typing yes here, I want to see your participation. Please type something. I'm looking at the chat. I'm reading it, okay? So if you want to participate, not if, you are going to participate, okay? So just participate. Just type something here in the chat, okay? Sounds good? All right, let's get started. Are you guys all focused? Everybody here? Okay, are you on your favorite couch in the house? Do you have your favorite pet? Do you guys have pets? I love pets, but I don't own one. All right, okay, let's get started. Why is chemistry important? You guys want to be dentists, doctors, AI, engineers? Chemistry can help with all of that. Can you tell me how? Especially with regards to, some of you want to be surgeon. Can you imagine being a surgeon not knowing chemistry? Can you tell me why is chemistry important? Exactly, Karma. We need chemicals. Yes, because you want to understand chemicals. That's a good one. Metab is here. Oh my God. Chemistry explains the basics. Yes, Sarah, the basics. That's a good one, Sarah. Medicine, medications. Who said medications? That's a good one. Okay. Mahmoud Ibrahim said medications. To know about all the matters. Duha said that. It's the main thing for life. Lana, that's a good one. To know about elements, because you get to know about chemicals and reactions. Ritesh, yes, thank you. Surgeons require chemistry since a lot of medicine and chemicals work with matter and chemistry. Yes, Jude, exactly. Whatever you inject your patient to get them to sleep and stuff, that's an organic substance. That's chloromethane. It's an organic substance. Chemistry important because it's a big impact on medicine topic, of course. Ahmed, thank you. Mustafa, thank you. Yes, that's right. States of matter. That's today's session. Understand how atoms work and interact with Mason, that's right. Manufacturing, exactly. If you guys are into engineering, you're going to be dealing with a lot of substances, right? You have to know what these substances are made from, what they do, how they react, right? To create vaccines, that's a good one. Okay, so vaccines. In engineering, you need them in fire alarms, for example. Like how everything works has to do with chemistry. Even motors, like how motors work, that's actually chemistry, right? That's electricity and magnetism. It's a little bit related to physics, but yeah. In engineering, yep, to vaccines. Okay, I got that. To explain the cells of your body. Yes, even biology is related to chemistry, very related to chemistry, right? What else? Nada provide excellent basis for understanding physical world. Muhammad Khalil, because it explains particles, atoms, everything around us. A lot more, they explain elements, compounds, mixtures. Yes, the explanation, right? You want to know what is it you're dealing with, right? And before you mix anything, do you guys, is anyone interested in mixing just two random things in the lab and just waiting and hoping? Anesthesia, yes, Jude, exactly, anesthesia. You guys are willing to mix two random things without knowing what they are and what's expected? Whoa. Okay, you guys need the chemistry course. Oh my god. Okay, absolutely not. Absolutely not. You do not want to mix two random things. Some people are very enthusiastic. Bro, yeah. Yeah, that's dangerous because you don't know. Okay, is 3 people said yes, I am willing to mix two random things. Are you guys willing to mix sodium? Okay. Sodium and water. Just water. Are you willing to mix sodium and water? Oh, instead of sodium, potassium. Are you willing to mix potassium and water? No, that's even worse. Exactly. Jude looks like he knows something. Good. Okay. How many of you help just a little bit in the kitchen? How many of you go to the kitchen? Yeah, you go to the kitchen. Good. Did you know that there's a lot of things in the kitchen that has to do with chemistry? Yep. Pots and pans are made of sometimes aluminum, sometimes stainless steel. The stove, exactly. The stove has a chemical coming out of it. It's a fuel. It's called butane. It's a butane gas. That's the name of the gas. It's called butane. So there is butane gas in your kitchen stove. And what does it do? It burns, gives you fire, gives you heat, and it cooks you stuff. Okay, and that's why we call it butane gas or butagaz. Butane gas. Okay, you get it? Butagaz? Okay. What else in the kitchen? Oh, do you guys have a fire extinguisher? Baking is chemistry. Exactly. So chemistry is everything. So can you guys tell me chemistry? Oh, digestion has to do with chemistry. Thank you, Feda. That's a good one. Thank you. Fridges use so there are chemicals going around behind your fridge to make your fridge cold, right? So yeah, that's a good one. Butane is C4H10. I love it. That's amazing. All right. Chemistry is the study of what? Excellent, Ahmed. Hannah. Sarah. Duha. Amira. Yep, kinda. Muhammad. Aweb. Oh, I like this name. Never heard of it before. Never met a web before. Nice to meet you. All right, so chemistry. Now, biology is the study of living cells, living things, anything that is living, right? Physics, which by the way, I love, but I cannot teach. Physics is the study of invisible things, force, energy, waves, light, right? You cannot touch these things, okay? Physics. Chemistry is the study of matter. Things you can touch, you can sometimes you can see it has a mass, right? So you can weigh it. It has a mass. It has or a weight, right? It occupies space, takes up space. Unlike physics, right? In physics, you're dealing with waves, force. I mean, how can you describe that? Okay. Good luck, physics teachers. All right. So, my second question for you is, what are the three states of matter? Yeah, momentum, Lena. Thank you, Lena. I mean, yeah, momentum. Like, how can you explain? You cannot even see that. Push and pull. Yeah, yeah. Okay. So, what are the three states of matter? Easiest question ever. I'm not going to ask easy questions anymore. That's the last easy question for you. Okay, thank you very much, everyone. Very good answers. Solids, liquids, and gases. Now, if you Google states of matter, you may see more, but that's all we need to know. Okay, now I have another question for you. When you were a toddler, when you were a 2-year-old, you could tell if something was a solid or a liquid or a gas. How? I mean, you look at a solid, you know it's a solid. You look at a liquid, you know it's a liquid. Like, how? Its shape. Thank you, Yusuf. Solids are stormily packed. Yes. The movement, the way they move, the physical state, the shape, the structure, the flowing properties, the flowing. I like the word flowing. Several people said flowing. How how they're placed in their containers. That's a good one. Properties, arrangement. Okay. So from the outside, when you see a phone or a box or a toy, when you were just 2, you could tell it's a solid, right? Why? Because it did not flow. So here is a solid. It did not flow. Not flow. For example, your phone, right? You put it on your hand, it doesn't fall. But if you put some water on your hand, what's gonna happen? It's gonna fall and it's gonna make a mess. I cannot dare to put just some water on my hand. I'm not gonna do that, right? So solids do not flow. Liquids, on the other hand, they flow, okay? For example, water, oil, that's gonna make a mess. You cannot just put it on your hand. You really need a container for it. All right, what about gas? When you were a kid, how did you know that this is a gas? Say, for example, this is a container, and all of this is a gas. I'm just gonna highlight it here in blue. What is the difference between liquids and gases? Okay, so some people said gases you cannot see and you cannot touch. That's a good answer. Yes, Yusuf, and yes, Sarah. That's what I'm looking for. Gases spread everywhere. They're gonna fill all your container until the top. You see the water, let's say, for example, this little bit of water, stays until here. It doesn't go all the way and fill to the top, right? Why? Because it's a liquid. It has a certain volume. It stays at the bottom. But the gas goes to all corners. Even like the smallest corner in your room will have a gas. Okay, so gas particles spread everywhere and go everywhere. Now, some people said that gases are colorless. They do not have a color. Yes, most gases are colorless. Can you give me an example of the most famous gas you have right now? Something you're breathing. Thank you. Exactly. Air is an example of a gas. It's actually a mixture of several gases. So air has oxygen, which we deeply need in our body. Why is oxygen needed in our body? It actually undergoes a chemical reaction. That's why chemistry is so important. What does oxygen do in your body, in your cells? Respiration. Thank you. Gesser, Julia, who else? Yasmin, yes. Everybody who said respiration. Lama, thank you. Yes, Mariam, exactly. Respiration, okay? There's also nitrogen in air. There's also a little bit, a teeny bitty amount of carbon dioxide in air. There's also argon in air. These are all colorless. But guess what? Some gases have a color. You guys have not seen a gas with a color before, but in a lab, in a chemical lab, you will see some gases with a color. Give me examples. Ahmed, excellent. Sarah, excellent. Smoke, so smoke has a color. You guys know that my PhD is about smoking cessation. It was about cigarettes and stuff, so I know all about bad cigarettes. Yes, smoke has a gray color because of the particles. It's basically carbon solid particles suspended in air. Ayudin Abdurrahman, thank you. Maryam, thank you. Lujain, thank you. Lana, thank you. Water vapor is colorless, by the way. It can look white because of something called condensation. Next class, we will talk about it. Brumi, Nireen, thank you. Nireen, thank you. Doha, thank you. Jana, no, ammonia is actually colorless. Potassium is a solid. It's not a gas. Hydrogen is colorless. Okay, great answers. Thank you very much. So some gases are colored, has a color, like chlorine is green, fluorine is yellow, and what else? Someone said bromine. Yes, bromine is reddish brown. We're gonna learn all about this, guys. Do not freak out. Okay, it's okay. We're gonna learn about this. All right, so just by looking at something from the outside, you could tell if it's a solid, liquid, and gas, or gas, right? So guess what? This could come on your board exam. Nice, right? These are just free marks. Sometimes they just give you 2, 3, 5 marks just for free. Hey, you guys can answer this, right? So an example of a question that come in board exams is to describe the shape of solids, liquids, and gases. How would you describe the shape? The shape. How to differentiate the shape of a solid, for example, like my phone, and the shape of liquid. Let's start with the solid. Solids have a fixed shape or depends. Yeah, it is a fixed shape, right? It doesn't depend. It has a shape that never changes, right? My phone is always like rectangular like this. It's not gonna have a different shape unless one of my kids breaks it or something, right? Not something I'm looking forward for. What about liquids? Does it have a fixed shape? Is this a fixed shape? I mean, look at this. It flows back and forth. Yeah, so it does not have a fixed shape. It is not fixed. Although it will take the shape of the container. So if I put it in a bottle, it will look like the shape of the bottle. If I move it somewhere else, then it's going to take the shape of that somewhere else. Thank you, Malak Yusuf. Okay, so yes, it is not fixed and it's going to take the shape of the container. Both liquids and gases will take the shape of the container. However, like I said in the previous slide, there's a small difference, not a small difference, it's a huge difference between liquids and gases. So here is a container and it's all filled with gas. This is filled with liquid. They both take the shape of the container, right? So this is a little bit round because the container is round. This looks like a beaker, like a cup, because it's in a cup, right? Mohammed Khalid, we're going to talk about Taiki Pact. That is I'm still talking about from the outside, okay? So liquids will not fill the whole container. It's not going to go all the way up and fill the whole container, right? Even if this thing is closed from the top. Say, for example, it is closed from the top like this. Will the liquid go all the way up to fill the whole space? No, it stays, right? Thank you, Sarah. Gases will fill the whole container. Do you guys know why? Why gases fill the whole container and liquids cannot fill the whole container? Okay, Mariam said something about density. Doha said something about movement. Because they freely move, arrangement. Okay, you guys have answers, but these are not the perfect, accurate answers. Okay, someone said the correct answer. Ala Ahmed, correct. Ala Ahmed, okay. All right, so you guys said several things about movement and density and dispersion and okay, you guys said several things, but the correct answer, I'm going to talk about the correct answer in just a few slides, okay? So the correct answer actually has the word forces of attraction. You will not understand this now, but I'm going to explain it later. And I have a whole class about forces of attraction and stuff, okay? So I'm going to talk about that later. All right, can you guys give me examples of solids? Examples of solids? Thank you, Amira. Oh, Hala or Hala? Yes, your phone is an example. A rock, a metal, a table, phones. Okay, a lot of people said phones. Ice cubes, meat, chair, food, plates. Thank you. Zoya is here. Oh my God. Your book. Thank you. Pencils, wood, grape. Okay, wonderful. Thank you very much. So a lot of people said something about phone, pencil, food. Are you guys hungry? I'm hungry. Someone said food. A lot of people said food. You guys made me hungry. Mouse, book, computers, devices, your glasses, everything. Slime? Yeah. Yeah, that slime that the kids play with, right? Okay. So I'm having trouble copying. Come on, come on, come on. Okay, I'm unable to copy my pictures. All right, can you guys give me an example of examples of liquids? Liquids. Juice, water, oil, water, juice. Okay, a lot of people said water and juice. Nice, nice, nice. H2O, thank you. Fuels, yes. Apple juice, perfume. Orange juice, motor oil, yes. Thank you very much. Okay, so iPad just remembered now to copy paste my pictures. Thank you, iPad. All right, so those were, yes, the most common example of liquids are water and juice and many other things you have at home. Oil, right? So water is all around us. Now, can you give me examples of gases? That one is hard because we can all think of one example, which is air, right? Okay, so here are examples of liquids. Now give me examples of gases. Okay, there are good examples here. Oxygen, carbon monoxide, nitrogen, helium. Helium is a good one because we use it in birthdays, right? Argon, nitrogen, methane, carbon dioxide, bromine, water vapor. Thank you. Hydrogen. Yes, that's right. So excuse me, most of these examples are in the lab. But in real life, what do we have? We have air, which is oxygen and nitrogen and carbon dioxide. If you go to the store, you can fill your balloons with helium, right? So that's another gas that you can get access to. It's completely safe. And remember that factories produce a lot of gases. Ew, some of them are not good. Eek, pollution. Not good for the environment. But anyhow, reality, yes. Factories will produce gases. Your water kettle also produces gases. All right, next thing is volume. Can you guys describe the difference between solids, liquids, and gases in terms of volume? What do you think about the volume of a solid? Volume of a solid. Is it fixed or it depends? Is it fixed or it depends? Yes, it's fixed, right? Your phone has a fixed volume. Well, I hope so. I don't want it to change in volume, get bigger, get smaller, and then not fit my pocket, right? Okay, so solids are fixed, and you can actually measure the volume of a solid. Does anyone know how to measure the volume of a solid? How can you measure the volume of a solid? Okay, here's a solid. How do you measure the volume of it? Length. Excellent, excellent. Who said that? Abdurrahman. Wonderful. Yeah. Several things. Amira, Shahd, Hamza. Wonderful. Okay. Length times width times height. Okay. Now, we don't really need this in chemistry, but I just wanted to link math with chemistry, right? Okay. What about liquids? Question. Is the volume of a liquid fixed or it depends? Fixed or it depends? Okay. Fixed or not fixed? Okay. 50% answered correctly and 50% answered wrong. Okay, let me ask you a question. Can you see this number on the screen? Can you see this number? What does it say? Can you see this number? Yes, Yasmin, exactly. That's physics. Yeah, it says, if you guys cannot see this, it says here 500 ml. 500 ml. What does it mean? It means that the volume of water is fixed. Now, I drank a little bit, so maybe there's 400 ml and I drank 100 ml, but it's fixed, right? Volumes of liquids are fixed. You can measure it. You can actually measure it, right? And Yasmin said something about in physics, you can actually measure the volume of a solid by placing it in a liquid and seeing how much the volume of the liquid increases. Do you guys remember this in physics? I'm not gonna get into physics, do not worry. Okay, some people got worried here. Okay, I'm not gonna get into physics, but you can measure. Yes, I love physics. Yeah, Jude says that was fun. You guys know when you go into not a swimming pool, when you go to the bathtub, okay, to take a bath, when you get into the tub, what happens to the water? The water level goes up, right? And you can make a mess, and moms do not like it. I do not like it when my kids do that, right? Yeah. If you also think about your water bottle, some water bottles will tell you how much water you have or how much it can fit. This water bottle can take all the way until 550 ml, right? So yes, volumes of water, of liquids, are fixed and can be measured. All right, now with the tricky question. Now this is hard. What about gases? What do you guys know about gases? Does it have a fixed volume or not fixed? Yeah, it's not fixed. And actually the volumes of gases is a little bit tricky. We will study all about the volumes of gases, mostly in A levels. We're gonna do something this year. We're gonna talk about some basics this year. But then next year, we're going to talk all about how to exactly calculate the volume of a gas, because it really depends on the temperature and the pressure. Okay? Now, in this class, the matter from inside, we're going to just go. No, before I get to that, if you have a speck of paper, okay? I have a speck of paper. This is a speck of paper. Can you guys see this speck of paper here on my hand, on my finger? You guys can see this? Okay. I want you to guess how many particles are in. Now, you guys just see a piece of paper, but do you know that it's filled with particles? Little things. Yeah, million. Thank you, Yusuf. Exactly. There's even though this is really small, but it actually has millions of things. Those things, for now, we're gonna just call them particles, okay? And the number of particles are a lot. No matter how much you make this speck really small, look at this. This is really small. Can you guess how many particles are here? Can you just guess how many particles are in this really small one? Exactly, Jafar. Still millions. Still millions. A lot. Okay? Now, these particles are specifically there are three kinds of particles. Does anyone know? And we're going to get into that later in the syllabus. Like, we're going to talk all about these particles the whole year. So what do you think these particles are? Yes, they could be atoms. And I'm going to teach you a whole lesson about atoms and what they are and how they look like and what do they have inside. And it is so much fun. Atoms are happiness, pure happiness. Or, Aline, thank you very much. They could be molecules. Or, yes, thank you very much. They could be charged particles, which we call them ions. So ions are charged particles. Charged means it is either positively charged or negatively charged, okay? All right, I can tell that Razan is very happy with your answers, guys. Razan is here watching your answers, and Rabia is here to watch your attendance and your participation. So that is amazing. All right. On the exam, I have another good news for you on the exam. They might sometimes, yes, Mohammed, that's right. They may sometimes ask you to draw the structure of a solid or a liquid or a gas. Duh, really easy. What you do is you draw circles to represent the particles, right? And this could be a 2-mark question. 2 mark as a gift for you, student, from the examiner, all right? Okay, so these particles, you're going to draw them in circles. How do you draw these circles in a solid? If it's a solid, how do you draw the particles in a solid? How do you think the particles in the solid are arranged? Aha! Boom, 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 right after each other. They are very close to each other. And so you're going to draw it like this. Here's a circle. Here's a circle. They are just right after each other and they are tightly packed. There's no spaces, no spaces. All of them are touching each other. Okay. All right. What about a liquid? Here's a cup of liquid. How do you think you want to draw the circles in the liquid? Haya, thank you. Lana, Maria, Doha, Jude, Karma, thank you. Layla, a little bit far from each other. Some could be touching and some are not touching. Some touching, some not touching. Okay. So thank you, Mariam. So some of them are touching and some of them are not touching. So this one is touching. This one is not touching. This one is touching. This one is not touching. All right. So the liquid is going to look like this. All right. What about gas? If you have a big container, how would you draw the particles of a gas? Thank you, Sarah. Sarah was like very far. Nireen is like far apart. Exactly. Far apart. So particles are really far apart. Okay, guys, if you have some particles touching like this, are you going to get the mark or are you going to get a 0? 1 mark or 0? Yeah. Big fat 0. No particles touching in gas. They are completely far. Completely far. No particles are touching. Okay. They may like hit each other and go back, but they're just colliding. Lena said they're just colliding. Colliding means hitting. They're hitting each other, but then they go back far from each other. Okay. So if you draw anything, yes, occasionally. If you draw anything like touching particles and stuff, 0. Okay. Next question. If the examiner asks you to describe the separation, how separated they are they separated or not separated? How would you describe solids? How do you describe separation in solid? Lena, thank you. Yusuf, Fairuz, hey, excellent. So separation in solids, you're going to say tightly packed. I want you to write this on the exam, tightly packed. Now, guys, on the exam, anything that makes sense, that is correct, that is understandable, you're going to get the mark. Okay. So, but sometimes students like really say something that is completely not understandable. So you have to be very careful with the words you say. Okay. They have to be scientific words and something that makes sense. All right. What about liquid? Liquid. Thank you, Yusuf. Less packed, loosely packed, slightly separated. I love it. All of this is correct, by the way. So you can say loosely packed and touching, or yes, slightly separated. They're like sliding over each other. Okay. Do you remember me, Dr. Mahmoud Ala? Oh my God, Mahmoud Ala. How are you? One of the first students to attend webinar more than 4 years ago with Yusuf, Sarah, Judy said, oh my God, Mahmoud, I love you. Where are you? You must be in your 4th year medical student. Guys, Mahmoud is in 4th year medical student. Whoa. Whoa. Thanks, Mahmoud, for joining. Are you in Cairo? All right. What about gas? What about gas? Freely packed. No, you cannot say freely packed because packed means they're close to each other, right? That's a weird word. Very far. Yes, I want you to say very far. Thank you so much for the participation. I love it. Yes, you're going to say really far from each other. Okay. Now we're going to get to the more difficult questions. For 43 minutes, I was going really easy on you guys. Now we're going to get to the real stuff. So please focus. Did anyone zone out? Anyone here who zoned out? No. Good. Everybody's focused. Maria zoned out? Oh, Albi, my heart, that hurts. Okay. All right, no zoning out. You guys focus. All right. So, what is the formula? Oh, you're joking? Okay, good, Maria, because my heart was like, I have a tiny heart and it's very sensitive. So, guys, please take care of me. Okay. This is water. You zoned out for 2 seconds. Okay, that's acceptable. Guys, 2 seconds is fine. Yusuf, you're okay. All right. Water. Now I'm going to teach you. Do not guys worry. I will teach you all about chemical formula and all. Okay. What is the formula of water? What is the formula of water? Good. Okay. So looks like everybody knows that the formula of, well, I have it on the slides. The formula of water is H2O. Okay. Water, I'm going to teach you later that it's a molecule because it has more than one atom. My question here, and it's a little bit of a question that I did not teach you yet, okay, but I will teach you this. How many atoms are in H2O? How many atoms are in H2O? Excellent, Yusuf, Hannah, Ahmed. Jafar, are you sure? Okay, a lot of students said 3. Some students said 2. So it's actually 3, okay? Because there's 2 H's and 1 oxygen. There's 2 H's and 1 oxygen, so 3, okay? So it has 3 atoms. In this first box, okay, you will see why I'm asking you this. In this left box, oh, you mistyped? Okay, good, good. In this first box, I'm going to draw liquid water. And what did we say about liquid water? We said it is circles, and these circles are touching each other. Duplicate, okay. They are touching each other. They are slightly separated, right? So all of these are water, okay? And then I'm going to draw water as a gas. In gas, it is really far apart. So I'm going to draw just 2 particles because it needs to be very far apart. Each of these circles is an H2O. H2O, H2O, H2O. So each of these circles has how many atoms? 3 atoms. It's a pretty small size molecule. Very small, just 3 atoms. You can never see H2O, right? Right now, I can see billions and zillions of H2O, but you cannot see just one H2O. It's impossible, right? It's just 3 atoms. It's very small. My question for you is, does the size of one water particle, okay, yes, so this is gas, which means it's vapor, okay? It's vapor. So this is vapor water, and this is liquid water. Is the size different, or is it the same? So I'm going to repeat the question. Same or different? Is the size of H2O in liquid same or different than the size of H2O in gas? Same or different? Okay. 80% said the correct answer. I love it. For the few students who were confused, you guys have the right to be confused. This is a hard question. This is the hard. I have like 3 hard questions today. This is one of the hard questions. I'm going to repeat my question for those who got it wrong. The orange one on the left and the orange one on the right, is the size the same? Is the size of the orange circle same or different in these 2 boxes? I'm going to repeat my question in a different way. How many atoms are on the left in this circle? How many atoms are there? 3. Good. Okay. How many atoms are on the right side in the gas form? How many atoms are there? Also 3. So, do you think the size is same or different? Same size or different? Ah, same size. Exactly. They have the same size. Now, why did some students say different? Because of the space that became larger. It's the space between molecules. But the molecule itself or the particle itself has the same size. It did not magically become 4 atoms or 5 atoms or 15 atoms. It stayed 3 atoms. H2O stayed H2O, whether it's solid, liquid, or gas. Do you guys get it now? And that was a tricky question. You guys see, it is not that bad, right? Okay, I have another more difficult question. So everybody focus, please. Jafar says, meh. If you guys think it's easy, it means you're smart, okay? That's a good thing. You know, be grateful. Yeah. All right, my next question. My brother was on a High Achiever 2023. Oh, Adam, thank you. Oh, wow, wow. All right, Adam Zeki. Oh, I know. You're Ahmed Zeki's brother, right? Adam Zeki? I know Ahmed Zeki. All right, okay. Next question. If the volume is the same, right? This is the volume, and I'm gonna pack it. I'm gonna put solid in it. Oh, Doha, I remember your sister, of course, 2023 course. She was amazing. I love her. I'm gonna put some solid here. I'm gonna put some Anas Zaki. Oh, okay, Anas Zaki. That's right. Yeah, he was smart. I'm gonna put some liquid here, and I'm gonna put some gases here. Okay, so the volume is the same. These 3 cubes have the same exact volume, but I'm gonna put solid here, I'm gonna put liquid here, I'm gonna put gas here. Okay, so let's just imagine I have this box. All right, and I'm gonna here. I don't like that one. Okay, here. Okay, and I'm gonna put solid here. I'm gonna put liquid in this, and I'm gonna put gas in this. Okay, and my question is, which of these will accommodate or will be filled with most particles? Excellent, Judy. Excellent, Haneen. Look at you guys. Karma, yes. Yusuf, Ale. Okay, let me repeat my question. Since the volume is the same, which state will have more particles? Which one will be filled with most particles? Rimes, excellent. Okay, so let's fill this thing with solid. How do we fill it with solid? It needs to be tightly packed, right? So here's a particle, all tightly packed. So how many did I draw? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I was able to fit it with 12 particles. Okay, let's go to liquid. How many particles can I fill in this? It has to be a little bit spaced from each other. They cannot be all touching. Some can be touching, but not all. So I'm going to fill it with liquid. Okay, how many particles was I able to draw? 1, 2, 3, 4, 5, 6, 7 particles. 7 particles. You see where I'm going? Okay, last one, gas. How can I draw a gas here? It's gotta be really, really, really far apart. So 1 particle here, 1 particle here, 1 particle. How many could I draw? Max. Like I can fit 3, maybe 4 at the most. Right? That's the max I could do. All right. So again, to repeat the question, if the volume is the same, which state of matter will have the most particles? Excellent. Look at you. Yes, solid will have the most particles. I could fit 12 particles, but in liquid, I could fit less. Okay? Thank you very much. Okay, that was a hard question. Can you imagine? That was a hard question. All right, next question that could appear in your exam, and it would be a gift for you. Describe the arrangement. The arrangement. When they say describe the arrangement, they're asking basically, are they regular or random? Yeah, thank you. In solid, they are regular. Okay? In liquids and in gases, they're pretty like everywhere. They are random. They can be going anywhere and everywhere. All right. So in liquids and in gases, they are random. And that's basically your answer. You do not need to say anything more. Okay. All right. Next question is talking about the motion. Motion means movement. All right. Okay. Guys, I told you in the first slide, chemistry is happiness. Why? Because chemistry is so similar to human beings, to people. Can you guys describe for me adults? Now, of course, I'm an exception, okay? How do you describe adults? How do you describe their movement? Do they move a lot? What do you guys think? Do adults move a lot? No. They are pretty sitting on their computers. Mustafa, I like that. Guys, I'm an exception. I'm not. I'm very energetic, okay? So, yeah, adults are usually sitting on their computer. They're pretty stationary. They do not move a lot, right? And that's actually very similar to solids. Particles in solids do not move. Okay, guys, how do you describe teenagers? Like you guys, teenagers. How do you describe teenagers? Yeah, they're kind of energetic. They move around. They go to the movies. They go to the malls. They, like, unless they're doing gaming, right? Okay. All right, so they are a little bit more energetic. They go outside and they hang out with friends and they're kind of moving, okay? So that's like liquids. Liquids are moving, but slowly, reasonably, okay? So they're kind of moving. All right. What about toddlers? How do you describe toddlers? Ooh, oh, those toddlers. They are all over the place. Thank you, Ahmed. Exactly. Absolutely crazy. They move everywhere, hyperactive, very random, very hard to catch them, right? Raising toddlers is not easy. So they are all over the place. And that's exactly solids, liquids, and gases, right? Chemistry is very similar to humans. So solids, how do you describe the movement of particles in solids? We're halfway through the slide. Oh, thank you, Razan, for yes, we have 43 slides, so we are halfway. Okay, how do you describe the motion of particles in solids? They do not move, but they vibrate. Okay, they vibrate in their fixed positions. So they do not move like liquids and gases, but they vibrate in their positions. Have you guys, do you guys have your phone on vibration? What does vibration means? It's like this, but it doesn't move. Your phone doesn't move, right? It's just vibrating in its place. So that's exactly what particles in solid do. What about liquid? So liquids are like teenagers. They move, but slowly. They move around and they slide over each other, but slowly, okay? They have a little bit more energy, okay? All right, what about not toddlers, I mean particles in gas? They move fast, like pew, 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 like they all over, all right? So this is the description of motion or movement in gases. All right, my next question is, I want to describe the energy. We call it kinetic energy. The word kinetic means movement. The energy of solids, liquids, and gases. Why do you guys think the particles in solid are tightly packed? Why do you think they're so close to each other? They don't have much energy. And they're actually similar to adults. What do you think about adults? Not very much energy. Again, I'm an exception, all right? So solids have very low energy, and that's why all they could do is just vibrate. That's it. All right, what about liquids? They have a little bit more energy, right? They have kind of high energy. What about gases? What about gases? Ooh, yeah. Very high. Thank you very much. Very high energy. Okay. So everyone participating on the chat, I love you. Thank you for participating. I'm watching and I'm reading your answers. Now, I have another question for you. How can you make a particle? Oh, thank you, Nureen. How can you make a particle have more energy and move faster? Exactly, Jude. Exactly, Yusuf, Hiba, Lina, Ahmed. Excellent. Heat it up. Give it more heat. So if you increase heat, the particles will gain energy and therefore it's going to move faster. So for solids, they're going to vibrate faster. For liquids and gases, they're going to move faster. Just like, therefore gain energy, therefore move faster. Just like giving a toddler some sugar. You guys know when you give toddlers sugar, what's going to happen? Ooh, no, not good, right? They're going to be moving all over the place. So that's oh yeah, sugar rush. My goodness. Okay. And so like when my kids were toddlers, I was pretty careful with what I feed them because if I give them sugar, ooh, it's going to be really hard parenting. They're going to be, exactly, Karma, they're going to be bouncing off the walls. Not a pretty thing. All right. Now let's talk about this thing that we talked about a few slides ago, remember? And we were like, oh, what is she talking about? Okay, so let's talk about the forces of attraction. The forces of attraction. So forces of attraction is a term that confuses some students. They don't like it, okay? But basically, forces of attraction is a force, a feeling that makes two things close together. So why are these two particles really close together? Why do you think these two particles are close together? Because there's something keeping them together. There's a strong force of attraction keeping them together. Now, what is this force? Not right now. Later in another class and a lot in the A level, I will teach you what these forces are exactly. It has to do with positive and negative. So do not worry about it now at all. Okay. So there is a force, right? An attraction happening between particles. I'm representing it with this red line. Okay. I have another question for you. Is the forces of attraction the same thing as bonds? Bonds, which we did not study yet. I will teach it to you. So the answer is no. Forces of attraction are not bonds, okay? Why not? I will teach you later, do not worry. In chapter 3, I will teach you exactly what is the difference between bonds and forces of attraction. For now, I want you to know that these are two separate concepts, okay? So the forces of attraction is what's keeping the particles together. Bonds is something inside the particle. Something inside the particle, from inside. So very different. Do not worry about it now. I will teach it to you later. Now, in solids have strong forces of attraction. And that's why the particles are very close to each other. What about liquid? So particles in liquid, let's draw particles. So here's a cup of water, for example. Here are some particles of liquid, okay? What do you think about the forces of attraction between the particles of liquid? A little bit weaker, okay? And that's why they are a little bit further. They're not tightly packed. So it's a little bit weaker. There are some forces of attraction, but not like the solid. All right? So far, so good? Okay. Now, let's talk about gases. Let's talk about gases. Say, for example, this is a gas container, really big gas container, okay? And here's a particle and here's a particle. What do you think? What do you think about the force of attraction between this particle and this particle? Is it strong or weak? Oh man, very weak. Very weak. That's why the particles are all really far. There's nothing keeping them close, right? And that's why they're so far, okay? And that's why it's very, very extremely weak. I think this group is very smart, right? Razan, do you agree? And Jenna, they're very, very smart. Yeah. Okay, I think we're having a very special group this year. And by the way, this part is in the Kahoot, so get ready. Yeah, Razan agrees with me. All right. Now, I want to ask you a hard question. You guys remember this slide when I talked about the shape is fixed, the liquid is not fixed? I want to ask you a hard question, okay? In liquids, the liquids will not fill the container, right? It goes until here and it stops. But in gas, it goes all the way, it goes to every corner and it fills the whole container. My question is why? My question is why? Why does a liquid not fill the container, but a gas fills the whole container all the way? What is the reason? Dispersion, no. We do not have this word. I already explained it, sorry. Volume and pressure, no. Who said volume and pressure? No, not volume and pressure, because they are free. Why? Okay, you're getting there, Mustafa. Why? Karma, excellent. Jude, excellent. Abdullah, excellent. Yes, why is it not fixed? Why is the volume not fixed in gases? Because of mass? No. A lot of kinetic energy? That's a good point, but there's another reason. Gases moves randomly into all directions. Why? Why? Hala Yasser, correct. Under more pressure? What if the pressure is normal? Density? Okay, liquids have more density. Why? Gases have weak... Is it bonds, Hamza? Is it bonds? Because liquids have fixed shape. Why, Ali? Because liquids have a fixed shape. Why? Because air with the liquid. Maryam, what if this is opened? Okay, that's a good point, Maryam. I know why. Maryam, yes, Maryam Muhammad, correct. Diffusion, no. Yes, karma. Okay, guys. Okay. Okay, good answers. Many actually were able to find the correct answer. Guys, I'm gonna repeat again. What do you guys think about the forces of attraction between particles in liquid? What do you guys think about these blue forces of attraction between particles in a liquid? Strong or weak? It's a little strong. It's not very weak, right? Because the particles are very close to each other. All right. What about in gas? What about in gas? Very weak. Very, very weak. Look at this. Very weak and therefore very far. That's why particles in liquid, because they have some kind of strong forces of attraction, they are staying in a very fixed volume. They're not flying everywhere. Did you guys all understand this part? Want to make sure. So it's the forces of attraction that explains why the liquids do not fill the whole container. They stay in a very fixed volume because they have, Mustafa, there are strong forces of attraction between particles. There's something keeping the particles together. Mustafa, do you understand now? There's some kind of a strong forces of attraction. Do you get it now? Okay? Like magnets. I love that. Yeah. And then in liquids, these forces are very weak. There's nothing keeping the particles together. So the particles are like everywhere. Okay? Muhammad, I'm going to repeat again. If there is a strong force of attraction between particles, do you think they're going to be close together or far from each other? Muhammad, the one who said I do not understand. If there's a strong force of attraction between two particles, like these two particles, okay, particle A and particle B, green and gray, if there's something keeping them together, if there's a strong force, are they going to be close or far? Muhammad, close or far? They're going to be, Muhammad, where are you? Yes, they're going to be close together, okay? And if the force between the gray and the green particle is weak, this is a weak force, There's nothing keeping the two particles together. Are they going to be close or far, Muhammad? Close or far? Thank you, Sarah. Thank you for people participating. Where's Muhammad? Yes, exactly. They're going to be far. That's it. You understand. Do you get it now? And so because there's strong forces here, the particles are going to be close together. Muhammad, do you get it? I just keep saying Muhammad because he said I do not understand. Yes, he said that he understands now. And there's weak attractive forces here, and that's why the particles are so far from each other. Okay? So far, so good. Guys, who likes summaries? Who likes summaries? I taught 27 slides. Who would love to see 27 slides in one slide? Who's into, yeah, me too. I love summaries. Okay, so here's a summary of the 27 slides all in one page so that it's easy for you to study. And by the way, I have a 12-page summary, just 12 pages for the whole syllabus, for the whole IGCSE in 12 pages. Definitely ask for it. I give it away for free. Okay? All right. So we talked about structure. We talked about how you draw on the exam. We talked about separation, arrangement, motion, kinetic energy, forces of attraction. One more thing I want to talk about. Yeah. Thank you, Roseanne. Oh, thank you, Vadim. All right. So, compressibility. Can you compress, squeeze, squish solid? Can you make this phone smaller? No, right? You cannot. Why? Because the particles are already close to each other. How else can you make them closer, right? You cannot compress solids. All right, what about liquids? Not compressible. Like books, laptops, you cannot compress it. Okay. What about liquids? So liquids are pretty, yes, some people said kind of yes. In liquids, particles are pretty close to each other. Look at this. I mean, they are to a very large extent very close to each other. So it's really, really hard to compress it even further. So I'm going to say not compressible. Okay. What about gas? Look at this. Look at this. Look at these far particles. Absolutely, yes, you can compress gases. Okay, now how is that helpful? Like, why is compressing gases helpful? Why is it a good thing? Why is it a good thing? Yes, gas syringe example is a good one. I wonder where's my gas syringe. I have everything. Like, I have lab equipments like all over right here. Why is it a good thing? Rimes, that's a good answer, so that it takes less space. That's right. So many of you at the beginning said they want to be doctors, right? A lot of you said they want to be doctors, right? So when you're a doctor and you're in a hospital, and you guys remember COVID days when people got sick and they had to go to the hospital and they had to be on oxygen, right? So all hospitals have to be equipped with oxygen cylinders, right? So do you guys think putting oxygen in regular cylinders at regular volume is good? I don't know why people are putting their phone number. Maybe someone asked them. Anyhow, they asked for the summary. Can you contact Ms. Dina, I guess? Yeah, okay, good. All right, so anyhow, let's go back to the hospital example. Those of you who are going to work in a hospital, do you guys want to store, focus please, everyone focus. We can talk about how to contact Ms. Dina at the end, all right? Okay, so if you want to store oxygen in your hospital, okay? Air is bad for body. Yeah. If you want to store oxygen in the hospital, do you want to store it at regular volumes? Regular volumes. Yes, no. No. Why not? It's going to be a huge volume. It's going to take rooms and rooms and rooms in your hospital. You're not going to have any space for patients, right? And so you definitely want to squish the oxygen into small volume so that it takes small space, okay? And so, okay, I have some pictures of gas, like gas cylinders and stuff. And so oxygen needs to be compressed, for example, in the hospital. What's another example of oxygen squished or oxygen compressed into a small volume? Yusuf, did you zone out? Ouch. Did you zone out? Just be honest. Be honest. Yeah, he did. He did. Thanks for your honesty. I love it. Yeah. Okay. So oxygen needs to be compressed in hospitals. Where else? Where else? Scuba tank. Yes. Divers. When you're diving, you don't want to take oxygen at regular volume. That's going to be huge, right? You want to squish it. Astronauts, thank you. That's a good one. Astronauts going to space, right? And so you don't want to be saving it in small tires. Yes, Aweb, thank you very much. That's right. Ooh, Ahmed Abbas, thank you. What is another example? Another gas that's squished in a small volume. Another gas squished in a small volume. And it's in your home. Could be in your kitchen. I have two in my house, because I'm going to tell you later why I have two in my house. That's a very funny story. Yeah, I'm not going to tell it here in this free session. I'm going to tell it to my students later. Okay. Yeah, fire extinguisher. Fire extinguisher. It has carbon dioxide under, like, very, very squished, very compressed. Okay? So, when a gas is compressed into a smaller volume. Say, for example, this is a gas normally big space, big volume. Yeah, Razan. And then I squished it into a really small volume because I want to use it in fire extinguishers. I want to use it for hospitals. I want to use it for astronauts, blah, blah, blah. Okay. When a gas, guys, everyone pay attention, hands on the keyboard, type this one word. When a gas is compressed, we give it a scientific name. We say that this gas is under high, Muhammad Khalid, when a gas is compressed, we say that this gas is under high pressure. That's right. That's right. You guys are amazing. Okay, those of you who, one person said he zoned out. Are you back? Are you back? Okay, good. All right, thank you. Thank you for answering. All right, so here's an exam question. And the exam question says, why does decreasing volume increases pressure? Why do we have a high pressure now? Why do we have a high pressure now that I decrease the volume? That is an exam question. Say, for example, it's 3 points. What should you write? There's less space. Thank you, Haneen. Because molecules are closer apart, hit each other. Ooh, look at this, Sarah. That is so good. Perfect answer. 3 out of 3. Less space, that's not enough. Okay, less space. Okay, so because when you have a decreased volume, there is less space, and therefore, is there a stronger forces of attraction? That's a good, no, Hannah, you cannot say that. You cannot say that. That is not the reason. There's another reason. I mean, the forces of attraction is as a consequence. So what happens when what is pressure basically? Guys, what is pressure? Why do we say it has a high pressure? What is pressure? What is the word pressure? You know what pressure is? Pressure is pain. You know when you say, oh, I have exam, I'm under a lot of pressure. What does it mean? Ah, pain. It's painful, right? So some kind of force. Yes, Sarah, force per unit area. That's exactly right. Some kind of pain. So why is there a lot of pain in B? What do pain mean? What is pain here? What is the pain? What is the force here? Ah, it's the collision. It's the hitting. The particles are hitting the wall. When particles hit the wall, collide with the wall, does a boom, 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 boom with the wall, we call that pressure. Okay? So which one has higher pressure? A or B? Which one is hitting the wall more frequently? A or B? So in A, the particles are far, right? And so every now and then it's gonna hit the wall. Every now and then it's gonna hit the wall. So it's gonna be like boom, 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 right? And Doha in B and Farida in B, its particles are really close to each other and very fast not fast, but they can hit the wall more frequently. So it's gonna be like what? Boom, 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 right? You get it now, Farida and Doha? And so in B, because the particles are closer, they're gonna be hitting more frequently. Instead of hearing boom, 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 it's gonna be boom, 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 like this. All right? You guys all understand the concept? Now, how do you say it in words? How do you express your understanding? You're going to say that particles are closer to each other because there is less space and therefore they boom, 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 boom. Can you write boom, 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 boom in the exam? You're going to write something scientific. What is that scientific word for boom, 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 boom? Collide, hit, bombard. Okay, I like collide. I like the word collide. So you're going to say that particles collide more frequently with the inner wall. Okay, easy so far? So far, so good? Okay, I have a question. If someone on the exam writes, particles in B have more energy, do they get a mark or do they get a 0? Thank you, Zaina. Do they get 1 mark or do they get a 0? If they say particles in B have more energy. Okay, I'm going to repeat. Did I say anything about the temperature temperatures being different? I did not, right? Let's say the temperature in A is regular room temperature, 25 degrees C, and B is also 25 degrees C. I did not say anything about temperature. It's the same. I did not heat B up. So I'm going to repeat my question. Ahmed Abbas. If someone says B has more energy and that's why it has higher pressure, will they get a mark or will they get a 0? Thank you. They're going to get a big fat 0. No marks. There's no, the temperature is the same, 25C and 25C. And therefore, particles have the same amount of energy. It's just that they are closer together. And that's why they're boom, 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 boom more in the container. Okay? Yes, temperature is the same thing like kinetic energy. If the temperature is the same, then the kinetic energy is the same. Another question. If student write B has harder collisions, instead of saying more frequent collisions, they said harder collisions. Thank you, Biba. 1 mark or 0 marks? 1 mark or 0 marks? Thank you. Look at you. 0. 0. It's not harder. It's the same energy because it's the same temperature. So it's the same kinetic energy. All right. If a student, one more question. If the student said particles are moving faster, if the student said particles are moving faster, 1 mark or 0? Some people got it wrong here. 0. Same energy, same movement, same speed, same energy, same speed. Yeah. Okay. If they say particles hit with more force, another big fat 0. Okay. You guys, you've got to be careful with what you write on the exam. That's exactly how people lose marks on stupid small things. All right. The speed of the particle and the energy of the particle and how active is the particle all depends on kinetic energy and temperature. That's it. You increase temperature, you increase movement and speed and energy and forces and boom, boom, right? But if you don't change that, it's the same speed, it's the same laziness, like same thing, okay? The only thing that happened here is that particles are closer and therefore they could collide more frequently, okay? All right. Did anyone have a problem with this slide? Did anyone have a problem with this slide? Okay, good. Look at you guys. Okay, I'm going to give you one more example about this. So, Doha, if you had any problems with this, I think the next slide will help. Let's say you're in a daycare or you're in a kindergarten room and you have some kindergarten kids, some toddlers, 3-year-olds in your classroom. You have 4 kids in your classroom and they are all over the place. Every now and then you will have a kid hit the wall because they are moving randomly and fast and in all directions and they are toddlers. All right. Now, you happen to need to move those 4 kids into a smaller room. You needed to move them into a smaller room. What do you think happens to the collision with the wall, the hitting with the wall? Yes, Maria. It's going to be more frequent. The teacher is going to suffer more, right? There could be some, oh, boom, ouch, boom, ouch, boom, ouch. But in room B, it's going to be boom, ouch, boom, ouch, boom, ouch, boom, 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 boom. Why? Because the space is small. Do kids in B have more energy? I did not say anything about energy. I did not feed them any sugar, right? So there's nothing here about energy. Okay? So if Jafar, can you put this in the Q&A because I cannot read this. Your statement is long. All right, I have another scenario. The room is the same size. The room is the same size. I still have 3 kids here and I still have 3 kids here and it's the same size. And all I did is I fed the kids sugar. What's going to happen in room B? I fed them sugar. I gave them sugar. Yeah. Oh no. Oh my God. They're going to be more energetic and therefore faster, and therefore, boom, 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 right? That's the same thing when I increase the temperature, when I heat up the container. Say, for example, A is at a regular, normal, reasonable 25 degrees C. B is heated up all the way to 85 degrees C. It's like feeding kids sugar. I give it a lot of energy. So what will happen? What will happen? A, particles are pretty slow, right? They're like moving and kind of slow, and every now and then it's gonna be like boom with the wall. What about B? Ooh, it's fast, boom, and it's gonna hit the wall. And that's why in B it's like boom, 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 boom. And therefore in B, they have more energy. They move faster. And when they move faster, they collide more frequently. And if it collides more frequently, boom, 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 that's more painful. What is the scientific name? We say that B has a higher, what is the scientific name? B has a higher, if there's boom, 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 is more collision. Mahmoud, excellent. Where's the word? Muhammad, excellent. Lujain, excellent. When there's more frequency of collision, we call it what? Amira, excellent. Ahmed Mahmoud, excellent. We call it what? Malik. Malik, sorry, not Malak. Malik, excellent. Karma, excellent. May, excellent. Guys, Yusuf, excellent. Maryam, excellent. Pressure. When there's more boom, 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 we call it higher pressure. So this is another exam question, and it says, why does increasing temperature increases pressure? What should you say on the exam? Why does increasing temperature increases pressure? Why does increasing temperature, I give it heat, and heat means what? Energy, right? Particles have more energy, and therefore they move faster, and therefore they, thank you, Doha, boom, 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 boom. You're not gonna say boom, boom, boom on the exam. What's the scientific word for boom, boom, boom? Thank you, Lena. Exactly, they collide more frequently with the inner wall, and therefore pressure increases. Is that easy, guys? Do you need to memorize anything? There's no memorization, right? You just understand the concept and you write what you understand. So gain kinetic energy, they move faster, they collide more frequently with the wall. Easy? When is Kahoot? Very soon. I have only 10 slides. All right, so what is the relationship between pressure and volume? If you have a lower volume, you have compressed the gas into a smaller volume. What happens to pressure? Pressure increase or decrease? Pressure increase. What do we call that in math? When you decrease volume, pressure increases. They are opposite directions. What do we call it? Thank you very much. Inversely, Malik, we call it inversely proportional. We call it inversely proportional. Okay, what about temperature? When you increase temperature, you make it hotter. Hot. Particles are energetic. What happens to pressure? Yes, pressure increase, and therefore it is called what? It is called directly proportional. Thank you very much. You guys are so smart. Okay, now guys, I'm kind of done, but I have 3 practical real life examples. Okay, thank you, Muhammad Ihib. Haneen, thank you. All right, real life examples. So my first example here, my first question here, what is an application of increasing pressure by increasing temperature? Something you can do at home. You increase the temperature, you heat up something, and the pressure increases. You do it at home, and your mom loves it. Pressure cooker. Thank you. So why do we love it? Because it cooks faster, right? So here's the pressure cooker. Okay, it is tightly closed, very tightly closed right here, right? You cannot It's not, there's no no leaks of the gas. And say, for example, here's your food, and here's your meat and chicken and spices and water and everything. And then the water is evaporating, right? The water is evaporating, and here are the particles of water vapor. And this water vapor is causing pressure, right? Yes, Yasmin, exactly, exactly. Okay, so this water vapor is causing pressure. Why? Because it's boom, boom, boom with the inner wall. It keeps doing boom, 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 boom with the inner wall. Now, how does the pressure increase? You simply heat up the container. You heat it up, the particles move faster, they collide with the inner wall more frequently, and it's like boom, boom, boom. It's like giving those kids sugar. All right. Okay, I have another. I thought food, I guess. I'm hungry. Oh my God, I'm hungry too. Okay, I have another real life example. The question says, why do balloons burst when you add more air? So you have this balloon, and there's a little bit of air, and then you kept blowing air. You kept blowing air into the balloon, and now the balloon has a lot of air particles. Why does it burst eventually? Excellent, Mahmoud Ibrahim. Particles collide. Excellent, Amira, Yasmin, Sama, Lana, Hamza, Abdul Rauf, Zaina, May, Doha. Look at you guys. Look at you guys. If the balloon has a little bit of air, I mean, there's boom, boom, right? There's a little bit of pressure. Little bit of pressure. What about this? Oh my God. Boom, 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 boom. So if there's a lot of boom, 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 what do we call this? It has a lot of, thank you, Neda, high pressure. Excellent. And that's why if the pressure is really, really, really high, eventually it's like, boop, it's going to explode. It's going to burst, right? And so the reason this balloon B, has more pressure and it will burst is that it has a lot of particles in a limited space, and therefore has frequent collisions. Okay, I have a question for you. Let's see who's been paying attention. I'm now gonna know who's been paying attention. Okay, here's balloon A, here's balloon B. Do particles in balloon B have more energy? Yes, no. Do particles in balloon B, Haneen, Jude, thank you, Hala, Mahmoud, Malik, sorry, Amira, Farida, Zaina, Ithar, Ritesh, look at you. Only one student had the wrong answer. You guys have been paying attention. 2 students have the wrong answer. I'm going to repeat my question. I'm just blowing a balloon. I did not say anything about temperature. I did not say anything about energy. Okay? And my question is, do particles in B have more energy than particles in A? Yes, no. The 2 students who answered it wrong, can you repeat? No, there's no more energy. They have the same energy, the same movement. Why? Because the temperature is the same. I did not say anything about energy. I did not say anything about heating. Okay? All right. Third real life example. Something I have personally encountered because I live in a place where the temperature drops to a severely low, dangerously low temperature. In the cold weather, sometimes your tire is gonna look lazy. Ugh, what is that? Flat tire. Why? Why in the cold weather your tire will have lower pressure and it's gonna look like this? That is not fun. Why in the cold weather the pressure drops in your tire? Why? So what happens to the air inside when the temperature goes down? What happens when the temperature goes down? What happens to the particles? They get lazier. They don't have much energy and they move slower. And when they move slower, what do you think of that about the boom, boom, boom? It is not boom, boom, boom anymore. It is boom, boom. It is really, really less frequent collisions. And that's why pressure decrease. Okay. And so because the particles have less energy, they are slower. Yeah, no boom, boom. Exactly. Thank you, Ahmed Abbas. And therefore they're moving slower. They are lazier. Right? I did not see this question on exams, but I thought I'd make you actually think today, and therefore less, they collide less frequently. Did I say more? Oh my God, I mean less. Where's my keyboard? Okay. They collide less frequently with the inner wall, and therefore pressure decrease. Okay. Now I have a question for you. And is this my last slide? Yes, this is my last slide. I have a question for you. Let's see who's been paying attention. What are 3 ways? Excellent, Sarah. Sarah is paying attention. She gave me 2 answers. Ala, Hanin, what are 3 ways to increase pressure? 3 ways to increase pressure. Yasin, Lujain, correct. Haya or Haya, yes. May, Yusuf, Muhammad, Farida, Ahmed, Khairi, Awab, Lana, Hamad Rifat, Zaina, Fairuz, Doha. Look at you guys. 3 ways to increase pressure, to increase the boom, 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 boom. How do you increase the boom, 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 boom? How do you make it more collisions? All right. Number 1, the most famous answer I got on the chat is increase temperature. Make it hot. Make it hotter. And what is a real life application for this? How do you do this at home? How can you do this at home? In the kitchen. Pressure cooker, right? So if you have a pressure cooker, you can fit all your food there, increase the temperature, and it's going to be boom, 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 and your food will cook faster. What's another way? What's another way? Squish the gas into a smaller space. Decrease the volume. Decrease the volume, right? Example. Oxygen cylinders in hospitals, fire extinguishers, right? Okay, one more example. How can you increase the boom, 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 boom? Increase the pressure. Excellent, Mahmoud Ibrahim. Excellent, Karma. Anyone else? Yusuf, correct. Third way. Lana, we just said the temperature. Gasir, yes. Sarah, yes. Increase energy. We just talked about the energy, which is heat, temperature, increasing temperature. Aweb, yes. Increase particles. Yes, Fairuz, that's right. You guys are right. You increase the number of particles. Just like a balloon. You just add more gas particles, and that's gonna increase the pressure. Example is, the balloon is one example. What else? Your tire, your bicycle, your car tire. And guess what? We are done. And we are ready for Kahoot. Just go to kahoot.it. More boom, boom, boom. Thank you. Just go to kahoot.it. We're going to play a game, and it's going to be fun. I have 15 questions. Most questions have 20 seconds or 30 seconds duration. So you have to be fast. Okay. Yes, there is a code. All right. And before I go to Kahoot, if you guys want to join the Cambridge WhatsApp group, and you can get the notes, my free notes from there. I'm going to post my free notes. You can go to the Cambridge group, or you can go to the Edexcel group, because the notes are just slightly different. Almost the same, just like maybe 2 pages extra in Edexcel and 2 pages extra in Cambridge. Very, very small difference. Okay. So please join your appropriate WhatsApp group. And Ms. Dina actually posted the link here. This is my phone number. Please contact me if you need. If you have any questions, please contact me. Oh, and by the way, these notes, I'm going to post it on the group. One more, before we start playing, one more announcement. I have completely free, the whole course is free. It's a pre-IGCSE course. It's for students in grade 8, just preparing for IGCSE. And it starts Sunday, August 24. If you want to join, if you have a sibling who needs to join, just join this one. Okay. And Ms. Dina also posted the link. If you are an AS, if you have a sibling in the AS Yes, make sure Iyad joins, exactly. If you have a sibling in the AS level, they can go to the AS Edexcel, joining this group, or the AS Cambridge joining this group. I have a free session on Monday and on Sunday. On Sunday for Cambridge and on Monday for Edexcel. All right, everyone ready? You guys have any questions? Does anyone want to? Someone have their hand raised here. Rania has her hand raised. Do you want to speak or no? She put her hand down. Okay. If you have questions, please raise your hand. Let's actually start the Kahoot right now if you guys are ready. What is the code? Let's find out. I don't know. Okay, so all right, here is this host live. Okay, by the time the Kahoot does its thing, do we have any questions? Does anyone want to unmute? All right, let's get started. And here's the pin. Okay, here's the pin. You guys start joining. The pin is 960470. Oh, thank you, Miss Saba. Oh, people started joining. Okay, I'm gonna be back in exactly 15 seconds. I'm gonna give you guys 15 seconds to join, all right? Okay, I'll be back. Okay, you guys ready? The link is kahoot.it. The link is kahoot.it. Here you go. Oh, did I send it to kahoot.it? Everyone. Oops. Ah, I put a slash. Sorry. Okay. All right, are you guys ready to start? Let's get started. Not even the correct answer. Kahoot K, right? Yeah, okay, here you go. Not good with this. I'm not good with this. Anyhow, all right, let's get started. I want this to be silent. And okay. I think we're ready. I think we are ready. Okay, start. And the code is going to be at the bottom. All right, true or false? First question, true or false? Doctor, can you show the WhatsApp code for a student wants? Solids have a fixed shape and volume. You have 10 seconds. True or false? Solids have fixed shape and volume. And the Kahoot pin is at the bottom. It's showing at the bottom. Of course it's true. All right. So, and then the nice thing about Kahoot, it's going to give you a scoreboard and it shows that Hiba is #1 and then Yassine. Guys, it is fun. It's a game. It's not a competition. We're having fun, okay? I mean, Yes, some are at the top here, but we're having fun. Okay. All right. Next question. How do liquids behave in terms of shape? 43 seconds. Fixed shape, but volume depends. Okay, that's volume, that's liquid. Fixed shape and volume. Neither shape nor volume are fixed. Fixed volume and takes the shape of the container. It's lagging. We need to win. All right, 19 seconds. So if I write this, do I get the 3 marks? The increase of energy due to heating up. Okay. Yep, fixed volume and takes the shape of the container. Thank you. All right, next question. How are particles arranged? Arranged in a solid, randomly packed and touching, far apart and random, tightly packed and regular, loosely packed and regular. You misclicked. Ah, Jude. Okay, yes, tightly packed. Thank you very much. Okay, Jafar, I'm going to answer your question. I hope you're still here. All right. How do particles move in a liquid? How do they move in a liquid? Oh, your Kahoot is laggy? Ach. Slide over each other slowly. They stay stationary. They move randomly with high speed, or they vibrate in their fixed position. The increase of energy due to heating up results in the increase of speed, therefore results in the amount of successful collisions. That is right, Jafar. That is right. Okay, thank you. Awesome. All right, next question. Yes, we will upload it to YouTube, Jenna. Which state has the highest kinetic energy? Highest kinetic energy. Toddlers! Highest kinetic energy. 17 seconds. You misclicked. Ugh. Gases, of course. All right. Question number 6. This game can cause you stress if you're dedicated on winning. Yes, I know, Jude. Well, yeah, don't worry about plasma. What happens when you increase the temperature? What happens when you increase the temperature? They stop moving, they lose energy and move slower, they gain energy and move faster, or they become larger. They become larger. Ah, okay, correct. Of course, they move faster and they gain more energy. Double points, pay attention. The size of water molecule is bigger in liquid than in solid. True or false? The size of water molecule is bigger in liquid than in solid. And we spent a good 10 minutes on that slide. True or false? You better get that right. Thank you, Jafar. Six seconds. The size changes? Does the size of water change? It's 3 atoms regardless. Of course it's false. I think the 9 people just misclicked because I know you guys are very smart. Okay, next question. Ooh, Matab is here. Fairuz, Omar, that's nice. Okay, which state has the strongest forces of attraction? Which state has the strongest forces of attraction? Strongest forces of attraction, and particles are very close to each other. Thank you, Jafar. He answered on the chat. 16-second, guys. I think everybody answered. 86 people answered. Okay. Yep, that is solid. Thank you very much. You guys are fast. Whoa. Whoa. All right, next question. Question number 9. In which state do particles fill the entire container? Fill the entire container. Yeah, we also spent some good time on that. I hope you guys did not zone out. Yep, thank you, Haneen. Thank you, Jafar. That's amazing. Do we have Kahoots every class? Not every class, but I have a lot of Kahoots. Good question, Ahmed Abbas. Last year, I had a lot of Kahoots. That is gas. Thank you very much. You like it, Ahmed? He wants it in every single class? Oh my God. I have it after each chapter. After each chapter, not after each class. If a volume is the same, which state will fit most particles? Which one will fit most particles? $77 answered. You misclicked, Habiba! Oh, solid! Because you can fit the most particles in a solid, right? I think everybody else misclicked. All right. Next question. Double points, guys. Pay attention. Double points, double points. In a solid form, particles have, focus, strong bonds between particles, or strong forces of attraction between particles, or weak bonds between particles, or weak forces of attraction between particles. Focus. Thank you, Jafar. That's right. He got it right. Look at you. Wow. 82 students answered in very few seconds. You guys are so smart. Oh, it's okay, Aweb. This is fun, guys. This is just fun. Okay? All right. Why is everyone misclicking? I don't know. I think they were nervous because it's double point and it's like they were just nervous, right? Yeah. Oh, Hamza, you realized the correct answer after. It's fine. We're learning. That's right. Strong forces of attraction, not bonds. Okay, very similar question. In gases, particles have gases, okay, gases, not solids. In gases, particles have strong bonds between particles, strong forces between particles, weak bonds between particles, or weak forces of attraction between particles. 32 seconds. Ooh, Lujain, that's good. Hanin, correct? Ah, Jafar, it's okay. All right. So, yes, weak forces of attraction between particles, not bonds. Bonds is a completely different concept. We're going to learn about it later. Okay, next question. Why does decreasing the gas volume, increasing pressure, squishing the gas volume increases boom, 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 boom? Why does decreasing the volume increases the boom, boom? Pressure remains constant. Particles lose energy. Particles gain energy. Particles get closer. Thank you, Hanin. Thank you, Jafar. They answered on the chat. That is wonderful. Oh, Mateb. Oh, I miss you too. You know, Mateb, this group is actually going to be fun. I'm very excited about it. Yeah. Yes, of course, Abdurraouf. They get closer. Of course, that's the correct answer. 5 seconds, guys. 3 seconds. Okay, yes, they get closer. I don't know why 16 people got it wrong. All right, Sara is at the top now. Increasing temperature increases gas pressure because increasing temperature, sugar, energy, craziness increases. Boom, 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 boom. Because, thank you, Hanin. Thank you, Jafar. That is correct. Yes, Abdurraouf, that's right. 23 seconds. MashaAllah, everyone is so smart. Yeah. Yes, Razan, I agree. I mean, the craziness was acted perfectly. Oh, my damn, yes, that's right. Okay, 9 seconds, everyone. I think everyone answered because we have 86. Yeah, I think everyone answered. Okay, 3, 2, 1. That is correct. The particles gain energy, and that's why they boom, boom, boom. Okay. All right, next question. True or false? Pressure is directly proportional to temperature. Pressure is directly proportional to temperature. Look at this. 64 students answered in 5 seconds. I am very impressed. Very impressed. Look at you guys. Okay, directly proportional to the temperature. Yes, you guys are right. As we increase temperature, we increase boom, 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 boom. Okay, so it is true. They are directly proportional. Okay, next question. It is true. I don't know why people said it's false. They probably misclicked. True or false? Pressure is directly proportional to volume. When you decrease volume, you increase the boom, boom, boom. So is that directly proportional? Thank you, May, and thank you, Haneen. Yes, Razan, I do not take offenses. I don't know what they said, but whatever. Yeah. I do, however, sometimes get upset when people say the wrong answer after teaching it several times. That's what I get upset about. Yeah. Okay, yes, that is false because it's indirect, it's inversely proportional. And I think we're done. Are we done? Yay! We're done. Okay, let's see who the winners are. Guys, it's a game. Omar Khalid, third place. Ala, second place. And first place is... Drum roll, Sarah! Okay. That is wonderful. Let me take a screenshot of this. Did it take a screenshot? Yeah, it did take... Oops. It did take a screenshot. Okay, done. I'm going to save it. That's amazing. Thank you so much, guys. Again, if you want to join the WhatsApp groups, yes, congratulations to the winners and congratulations to everyone who played with us today. I think it was real fun, and thank you so much for everyone who attended. Please join your appropriate group. You like it, Yasmin? You like the Kahoot? I have it every chapter. Yeah, you like it? Okay, good. Okay, maybe I can do more. If you guys like it, I can do more. It is so competitive, and I guys want you to relax and I want you to have fun. I don't want the stress, okay? So yes, Mateb also says, yes, please. Mateb, are you my 2023 student or you're new? Because her name was also Mateb Tariq. Yes, you are my 2023. Okay, good. Is there a WhatsApp group for all students? So Ahmed, the reason I separated the WhatsApp group is that the notes are slightly different. So I want you to have your correct notes. Okay, just join one of them. All right. Is there any other questions? Do you guys have any other questions before I leave? Anything else? Was it all good? We finished in under 2 hours, and I have 2 minutes to 4 minutes. I finished 4 minutes early, right? Look at me. Thank you, Yasmin. So good. Okay, Jude, thank you so much. Adam, thank you so much. Ahmed Abbas. Maria, okay, thank you guys. Where's the QR code for your number? Okay, my number. Here's my number, guys. Okay, you can text me. Oh, thank you, Jafar. You're so sweet. It was fun. Yes, thank you. That's my goal. Abdul Rauf, thank you. Thank you so much. That's amazing. Guys, please save my phone number. Please join your appropriate group. Definitely have my phone number. Definitely have Miss Dina's phone number and Miss Saba's phone number. I think they posted it sometime during the session. With the grade 8 thing, Nada. Okay, here you go, Nada. Nada, this is the one. So this is for siblings. Make sure your siblings also join. So younger siblings can go to the grade 8 course. Older siblings can go to the AS course. So all grade 8 course is free. The whole thing, all the way, like 6 months free course. And it's going to prepare them so well for the IGCSE. Definitely do not miss this. I mean, it's free. Come on. And for AS, we have a really fun class. It's going to be real fun. And I have Kahoot for them too. The first session is free. So also do not miss this because it's going to be so much fun. But it's only for the AS students. If you're not AS, you will not understand a thing. So, oh, Karma. Oh my God. Look at the hearts. Orange and red hearts. I love it. Thank you so much. All right, guys. Thank you so much. Any last minute questions? If you guys want to speak on the mic. Hello, miss. There are 12 pages of chemistry sent on both groups. Yes, I can send them. Just remind me, Yassine. Okay, just remind me and I will send it. Okay. Yes, this group is amazing. I love it. I agree, Razan. All right. Thank you for the purple heart, Farida. I like hearts. Guys, I mean, give me the emojis. I love them. Love them so much. Thank you, Neda. Yes, so looking forward to see you, Neda, on Wednesday. Our next session is Wednesday, the 20th. Layla, also looking forward to see you. I know you already enrolled in the course, so looking forward. Adam, looking forward to see you. Today's session, Rania, was for year 10. Okay, if you're year 8, then you need to go to this course, which will start August 24. Rania, do you get it? Rania Gamal, you get it? Oh, Julia, thank you for the emojis. Thank you for the emojis, Julia. Okay, so Rania, if you're a grade 8, if you still are not yet an IGCSE student, definitely join my free course. It's my first time teaching this free course, but it's going to be so good, I promise. Okay? And it will give you homework. Okay? Oh, Abdul Rauf, you're going to year 9? I think this course is best. Yeah, to finish chemistry. Grade 10. You're going IGCSE. Sama, join this course, which started today. Today was the first lesson. Next lesson is Wednesday. So our lessons are Wednesday and Saturday. Yes, join the normal course, this one. So if you are already an IGCSE student, like grade 9 or 10, join these courses. We're starting Wednesday, so make sure you enroll. Your grade 11, Yasmin, are you taking the IG this year? Then join this course, okay? So I joined the one for grade 8, or you mean this group, Abdul Rauf, this one? Join either this or that, okay? Grade 8 extended or core? Adam, that's a good question. Neither. It's the basics of chemistry. I'm going to teach the basics of chemistry. I'm going to make sure you are well prepared for IGCSE. I do not teach the core. No, I'm sorry. Oh, got you, Yasmin. Okay, got you, Yasmin. Okay, so definitely join this one. Really looking forward to seeing you. Anything else, guys? Thanks. Yes, Razan, thank you for the message. That's exactly what I wanted to say today. Thank you so much. Year 7 can join year 8, Rimes. Yeah? You're going to be ahead of the game. Don't you love it when you're ahead of the game? Right? Okay. Thank you so much, guys. Love the participation. Love the energy. This group was the best. I really love it. Thank you so much. See you Wednesday. Please join the groups. Please text me if you need anything. Any other questions? No other questions. Amazing participants. Take care, you all. Thank you so much. Have a good day. Enjoy the rest of your day today. Bye.